Hello everyone. Today I will be commenting on the headline that ChatGPT made theoretical physics discovery. I guess let me show you what I'm talking about. I guess it's OpenAI website, and here they give description of what was done. And here are some articles about it in Science, and well, okay, I guess it's also the same source. Physicists collaborate with ChatGPT to make a breakthrough discovery. So I decided to have a look what was actually done there, and how relevant it is, and was it actually breakthrough. Here is a paper which they're talking about. I would like to comment on the authors first. At least two people here are kind of well-known physicists, at least to me. David Skinner is an inventor of ambient twistor strings, and Andrew Strominger, I think, is even more famous for the paper he co-authored with Cameron Waffa, in which they derived Hawking's black hole entropy formula from string theory. So yeah, this is a paper by well-known authors. So the results could be significant. Well, let's see. I will read you the first paragraph, so at least you have an idea what this paper is about. The laws of physics are succinctly, you know this word, encoded in scattering amplitudes, which gives the quantum probabilities for any given collection of oncoming particles to collide and produce any given collection of outgoing particles. Yeah, that's what we measure on colliders, that we collide particles and calculate the probabilities of outcomes. These amplitudes may be systematically derived from the Feynman diagram expansion, which determinably sums over all possible quantum processes. Yeah, that's also, I think you know, right, the Feynman diagrams techniques for calculating them. The theoretical results from the Feynman diagram expansion of the standard model agree with experiment to an unprecedented 14 decimal places. Yeah, so it's very strong method. Yeah, it's actually, theoretical physicists are proud of it. Talk about it every time they have any chance. But here is an interesting part. In practice, the computation of scattering amplitudes can be extremely difficult. Among other obstacles, the growth in the number of Feynman diagrams for an n particle amplitude is faster than exponential in n. However, despite this apparent complexity, cancellations lead in a variety of contexts to a very simple final answer. This indicates that our present understanding of the quantum laws of physics is seriously incomplete, and there is a more efficient formulation is needed. The last few decades have seen much effort in this direction and delivered promising insights. Well, I guess I will cite amplifidron and Nimar Hamed ideas, which I think I even reviewed at some point on my channel. So yeah, you see, there is some sort of great mystery. If Feynman diagrams work so well, why they're so computationally ineffective? Why in many cases there's always a simple answer in the end? And I guess that's what excited them, and they decided to study this phenomenon more. And here they're talking about, well, some special amplitudes of gluons. So it's a particle which carries strong interaction, right? The one which binds quarks together inside protons in a very, very special setup with special helicities. And they trying to find simple formulas for them. That was actually they're trying to do. They send it divided into chambers in momentum space. How do you say? Yeah, kinematic space of all possible momentums and velocities of all incoming or outgoing particles. And in some chamber, they was able to derive a nice expression for it using what's it called? I don't know, Bernoulli-Gale recursion relation. I know it's some old topic. I never studied this myself. But it's some simple, I guess, consequence of water densities. I don't know exactly, something like this. Yeah, we give a simple formula for a special region, a special kinematic region for all n. N is the number of gluons. And here they finally get to the point where they use ChatGPT and how. The key formula, 39, we'll see it below, for the amplitude in this region was first conjectured by ChatGPT 5.2 Pro and then proved by new internal OpenAI model, so I guess not released to the public yet. The solution was checked by hand using the recursion and was moreover shown to non-trivial basis of theorem. Cyclicity was Kleist-Gurdjieff and you want decoupling lengths. I don't know, maybe we'll get to it. Okay, I guess that's all. That's what OpenAI did here. Well, let's see what where it used in the main body of the paper. Here they introduce some notations. It's called Snorkelicity variables for momentum, and well, other notations for amplitudes, some auxiliary quantities which amplitudes are expressed in terms of, like, for example, an is the amplitude, I guess we should be working with. There's some auxiliary quantity, Parquet-Taylor factor, and so on. Here they explain what is the special regime they're working in. And how the amplitude simplifies in this case. And here they're talking about how you could derive the recursion relations specifically for these simplified factors. Yeah, I guess here they are. Now, this is a consistency check which they're talking about, which I'm not going to mention, I guess. But they have each has some physical meaning. Yeah, this is a famous Weinberg-Soft theorem. Okay, and now we get into concrete examples. So they calculated this amplitude in a simplified region, and they got these formulas. Now they're saying that, oh, it's kind of too difficult, let's pick even more special condition. Yeah, so this kinematic region which we're talking about. And then the formulas got easier. So the formulas from above, they got simplified to these ones. Now here's where ChatGPT comes into play. At first the open release to the public model, how to look at this expression and guess the general formula. Here is the answer. Here's what ChatGPT did. Well, I don't know, you could judge for yourself how difficult it was. Was it really difficult or not? Because, well, let's look at the expression. For A123, for example, SG1 2 plus SG2 3, then for 1 2 3 4. SG12 plus SG23 times SG34, SG41. Then for A1, 2, 3, 4, 5, 1, 2, 2, 3, 3, 4, 1, comma 2, 3, 4, 5, 5, 1. So as you can see, I guess the key was to notice that these factors actually, these factors actually similar in each product. It just goes like this: 1, 2, then 2, 3, then 1, comma 2, 3, 3, 4, then 1, comma 2, 3, 4, 4, 5, and so on. And here is probably some sort of symmetry used to say that 1, comma 2, 3, 4, 5 is actually the same as 6, 1. So I don't know. It seems like humans could have guessed it if they tried hard enough. But why would you do this even if AI can do it for you? So that's how AI should work. It simplifies this kind of stupid operations, right? So I would say well done. I won't call it a breakthrough, however, because yeah, that's a very technical problem and humans can do it. And then they used supposedly the scaffolded non-released to the public AI model to prove this formula. Yeah, however, yeah, I found that it was running for 12 hours. So it was something quite non-standard. And I would say in 12 hours, well, humans could do it too. Yeah, I don't know. It's still good. I mean, it's still great that ChatGPT could now produce correct, accurate proofs, at least for some straightforward formulas. Yeah. But I wouldn't call this a breakthrough discovery. And this headline is at least kind of more correct. However, again, it's more like those people derived the result and ChatGPT kind of helped them guess the simplified formula and prove it. So yeah, that's what was done here. I don't know how excited people got about it. I would say it's still impressive that the simple LLMs could do something like that. But I think you should not expect any kind of deep reasoning from them, just from the understanding of how they work. Right? They're not, they couldn't really produce anything fundamentally novel because they would do just kind of scan through the all known texts and spit out the most probable result. So it's very kind of linguistic level of understanding. As my friend Liam put it concisely, imagine if all people in the world are wrong about something, then any LLM has to be wrong as well, just by construction. And that's kind of what we mean by, a breakthrough discovery. When everybody was wrong about something, somebody come up with something fundamentally new. I don't think it's happening here. By the way, it's not the first time I came across somebody is kind of trying to, well, hype AI up by claiming that it made some sort of theoretical physics discovery. Like, I was watching this video where the person makes a case for the absence of the AI bubble. And here's what he says in one of his points. He made a lot of points, and in some place he gonna casually say something like this. Like it's a comment on intelligence of current AIs. Yeah.
Let's take a look at our distorted view of intelligence. Not long ago, before ChatGPT, AI wasn't even as smart as a chimp. It couldn't reliably identify a hot dog. We laughed at it. That's adorable. The funny robot can do monkey tricks. But now, it's discovering new laws of physics. Yes, that's a real story. Sources in the description.
Yeah, okay, so mm, let's find it. Mm, here, here's what he's talking about. Well, okay, just kind of zoom in a little bit. So yeah, let's read what they actually do. So physics-tailored machine learning reveals unexpected physics in dusty plasmas. Okay. So dusty plasma is a mixture of ions, electrons, and macroscopic charged particles. It is commonly found in space and planetary environments. The particles interact with Coulomb forces mediated by the surrounding plasma, and as a result of this Coulomb forces interaction, the effective forces between particles can be non-conservative and non-reciprocal. Well, okay. Machine learning models are promising road to learn these complex forces, yet the structure should match the underlying physical constraints to provide useful insights. Here we demonstrate and experimentally validate an ML approach that incorporates physical intuition to infer force laws in a laboratory dusty plasma. Trained on 3D particle trajectories, the model accounts for inherent symmetries, non-identical particles, and learns the effective non-reciprocal force between particles with exquisite accuracy. We validate the model by inferring particle masses in two independent yet consistent way. The model's accuracy enables precise measurements of particle charge and screen length, identifying large deviations from common theoretical assumption. Our ability to identify unknown physics from experimental data demonstrates how ML-powered approaches can guide new roads of scientific discovery in many body systems. Okay, so and so on. So what does it actually mean? So imagine you're trying, well, you have some sort of data set, and you're trying to kind of identify a certain trend in this data set. Like, for example, if you have dots which lie on the line, you could, approximate it by a linear function, and so on. So here the trend could be just way more difficult, and instead of approximating by a linear function, we use special function which is built from these layers of neural network, right? We have just linear transformation sandwiched with activation functions. That's what it actually is doing. You feed some data points into this neural network, and then you minimize the loss function, right? You make the output kind of approximate your data set well, and then this this trained model gives you a trend which you use and can use to make predictions. The subtle problem here is only how to incorporate the symmetries of the data set, which come from physical constraints, into the neural network structure to make training more effective, like I was trying to say here initially. So that's how it actually looks like. And by the way, astrophysicists were using these techniques way before all the AI hype. So this paper might be new, but the approach is not really new. So yeah, don't be misled. It's not like these researchers ask some general reasoning model like ChatGPT, hey, could you look at this data set and make sense of it for me? And then, well, yeah, I look at it and said something like, well, okay, the information you provided to me and with all the research I've done on the internet through across all other papers posted on archive makes me certain that the data you give me is consistent with something like a dust on the lens of your telescope or something like that, or maybe dust in some clouds or something like this, or dust in in the intergalactic or interstellar media. That's not what's happening here. It's more like approximation of your data set by a special function which has the ML structure. And by the way, even when general reasoning model will actually give advices like that, I still wouldn't be surprised, because yeah, soon I think they will be capable of doing this, and they are good at finding useful papers across the internet and squishing information out of them and giving it to you in more effective way. So yeah, it's possible that at some point AI will be able to identify the correct pattern in your data just by reading other publications. I think it's not unexpected. So AI will be able to make this incremental progress in physics. But this incremental progress in physics is not what really I care about, right? It's yeah, it's true. AI will be able to replace all those paper grinding physicists who sit in all those sort of universities and getting the grants and publishing hundreds of papers per year to sustain the funding, just to kind of feed the families. Yeah, it will be actually great to replace them, because they're not making real progress in physics. At least not a breakthrough progress. So, well, yeah, I'm impressed with what AI can do, and I'm really glad that it's happening. But the reason for that is because I want those kind of paper grinding physicists to disappear, and for humanity to understand that well, science is not about that, and to make people value actual progress more. And I also hope that one day people will give up on LLMs and we actually will be able to, I don't know, go get to actual mimic of human thinking, because LLMs are just not doing it. I think this will only be possible after the bubble bursts. So he's also trying to make a point here that there is no bubble at all. But I don't think that's quite right. Know what he's saying.
Some people see a line going
Okay.
up and to the right and think, bubble. Stock market crash waiting to happen. But stock prices measure investor sentiment, hype, fear, greed. They go up when people feel optimistic and crash when reality disappoints. But technology curves measure reality, not feelings, capability, physics. Moore's law didn't pop after 50 years.
Well, but to be fair, yeah, it did pop. I think it stopped working around 2017 or something like this. So yeah, exponential growth doesn't continue forever.
Chip power kept doubling because the physics allowed it. The meter trend isn't measuring hype, it's measuring what AI can actually do. Bubble implies bullshit, fake. But this isn't fake. This is real exponential progress in economically valuable work. So this is the current plan of the AI companies. Optimistically, they claim they'll take your job. Pessimistically, they say they might destroy the world.
So yeah, I don't think this is quite correct to think about it like this. So yeah, AI makes real progress, but there's still a bubble. It's similar to dot-com bubble. Like internet is a real thing, and it's certainly important, but at its beginning, there were many companies which were not really making profits, and people, well, investors didn't quite figure out yet how things work and which companies you should fund and which you should not. So when bubble bursts, unprofitable companies just disappear, and it finally opened the door for actual progress and structural change. So I hope that the same will happen here with AI. That OpenAI and all these LLMs will burst, and we'll get something different. So I guess I'll end it here. I have not much more to say. See you next time.